All right, today we're going to talk about dot products. Dot products are found in your textbook in section 9.5. The important thing to remember about a dot product is when you multiply two vectors together, that's called your dot product, you will not get a vector. When you add and subtract vectors, you're going to get a vector. When you take a scalar, which is a real number, and multiply it to a vector, you're going to get a vector. But when you find the dot product of two vectors, you're going to get a scalar, which is a real number. Okay, so in order to find the dot product of two vectors, you have vector v and vector w. You're going to take your first number and multiply it to your first number in this vector, in this case a1 times a2, and then you're going to put a plus sign in the middle, and you're going to multiply b1 and b2. So multiply your a's, multiply your b's, and then add them together, and that's going to give you a dot product. And again, when you get a dot product, you're going to get a scalar or a real number. Now, a dot product has some different names. If you'll note here on the side, a dot product is also a scalar product or an inner product. So if you see those words, you'll know that you're finding your dot product. And again, it is not going to be a vector. It is going to be a real number. So if you look at number 1 and number 2, I've worked those out for you already. If you're finding the dot product of vector p and vector q, put your little multiplication dot there in the middle. Take 5 and 1 and multiply those together. Then take -2 and -9 and multiply those together, and you'll get 5 and 18. And then take those two products and add it together, and that's going to give you a dot product of 23. Do you see how your dot product is a real number? So it's a single number, it's not a vector. Now, if you look at number 3, this vector is written using I and j, but it's still the same concept. You'll multiply your i's together, 7 times, this is a -1, plus multiply your j's together, 8 times -9. So 7 times -1 is -7, 8 times -9 is -72, and then add those two values together to get -79. Now -79 is your dot product. Again, it's just a scalar. It's a real number. It's not going to be a vector. Okay, so that's how to find the dot product. It doesn't matter what form it's in. It's going to be the same thing. Multiply your first ones, multiply your second ones, and then add them together. First, second, and then add them. Okay, now our next note says if two vectors are perpendicular, then their dot products are equal to 0. And these type of vectors have a special name. If you have a dot product of 0, you're considered to be orthogonal. So on 5 and 7, we're determining whether the vectors are orthogonal, so that means I have to find the dot product of each one. So let's do the dot product of m and n. Okay, so take 3 and multiply it to -28. Take 7 and multiply it to 12, and then add the two products together. So 3 times -28 is -84. 7 times 12 is +84. Well, when you add opposites, what are you going to get? You got it, 0. Okay, so if your dot product is 0, then that tells you that your two vectors are perpendicular. So if it's asking if these two are orthogonal, we can say yes. Or we can say orthogonal, or we can just say yes, either one. Now this is written in I and j form, so multiply your i's, -5 times -1, and then multiply your j's, -1 and -5. That's going to give you +5, and that's going to give you +5, then add them together to get 10. So my dot product is equal to 10, which is a scalar, a real number. It's all well and good. The only thing that is telling me is that my two vectors are not perpendicular, so they're not orthogonal, so I can just put no there. Okay, now in this last section, you have some properties to write down. So the dot product of v and w is the same thing as the dot product of w and v, according to the commutative property. If you add vectors v and w, and then use whatever you get to get the dot product, it's the same thing as the dot product of u and v plus the dot product of u and w. Okay, that's the distributive property. Now if k is a scalar and you find the dot product of here and then you want to multiply it times k, it's the same thing as finding k times v and then finding the dot product of whatever you get times this, and then, or k times w times vector v. You're going to get the same result. And if you're multiplying times 0, we know that's 0. And then the dot product of a vector in itself is equal to the magnitude of that vector squared. Now, this is important because we're going to use it on the next page. So, on the next page, we're rewriting what we just looked at. The dot product of a vector in itself is equal to the magnitude of that vector squared. So, we can then say, if the dot product of a vector in itself is the magnitude squared, then the magnitude of that vector is equal to the square root of its dot product. Okay? We've done this before, so I only did one example here. If you're finding the magnitude of vector r using a dot product, you're just doing r times r, which will be 10 times 10 plus 24 times 24, which will be 100 plus 576, or the square root of 676, which is 26. We already do this, okay? The magnitude of vector r is 10 squared plus 24 squared, okay? We've been doing this, but it's just showing you it's also the same thing as a dot product. Now, to find the angle between two non-zero vectors, v and w, this is the formula that we need. Cosine of theta is equal to the dot product of v and w over the magnitude of vector v times the magnitude of vector w. Okay, and here is vector v and w. We're looking for the angle between the two vectors. Now, if the angle between the two vectors, when we use this formula, is 90 degrees, that also tells us that our vectors are perpendicular. But if the vector is 0 degrees or 180 degrees, that tells me my two vectors are parallel, okay? Now, it's not 0 to 180, it's 0 or 180 degrees. That gives you parallel. All right, so find the angle between each vector pair. We've got vector u and vector v, so I'm taking my formula here and I'm plugging into it. Cosine of theta is equal to the dot product of my two vectors. So I'm multiplying 8 times negative 7 plus negative 7 times negative 3. And then I'm finding the magnitude of this vector times the magnitude of this vector. So I went ahead and plugged this into my calculator. 8 times negative 7 plus negative 7 times negative 3, that's negative 56 plus 21, so I got negative 35. Now, I want you to be very careful here. We could plug all of this into our calculator and get a decimal where we'd have to round, but we'd have to round, and then we'd have to round again, and our answer is getting further and further away from our precise answer. So even though it's not ideal, what we're going to do is we're going to simplify this. 8 squared is 64. And then we are going to do negative 7 squared, which is 49. So 64 plus 49 is equal to 113. So we get the square root of 113. I'm not going to try to simplify it in any way, shape, or form. Okay? On the next one, we have 7 squared is 49 and 3 squared is 9, which will give me 58. So I have negative 35 over. Since both of these are under radicals, it's perfectly okay for me to take 113 and multiply it to 58 to get 6,554. Now, we all know this is not something that we would leave in a normal answer. We'd get rid of that radical in the denominator. We see if we could simplify it, anything. But we're not worried about what this is. We're trying to find out what theta is. So I know that the cosine of theta is equal to negative 35 over the square root of 6,554. So I'm going to find my inverse of this. And that's why I'm not simplifying it, because I can take this and plug it into my calculator. So let's do that. We have second cosine, okay, and we are going to do negative 35 divided by the square root of 6,554. Okay, so that's going to give me 115. Let's do 2 decimal places, 115 and 62 hundredths degrees. So theta is 115 and 62 hundredths degrees. So this is the angle between our vector pair. okay? It doesn't equal 90, it doesn't equal 0 or 180, so we don't have perpendicular or parallel vectors. That's just our angle between vector u and vector v. All right, let's see what we can do with number 15. So the first thing we're going to do, we've got cosine of theta is equal to, let's find the dot product, 6 times 9. I'm going to go ahead and write that down as 54. And then 7 times negative 6 is negative 42. Over the magnitude of vector A, so 6 squared plus 7 squared, okay, times the magnitude of vector B. So that'll be 9 squared plus negative 6 squared. Okay, let's go ahead and add these two together. That's going to give me 12 in my numerator. Okay, now down here I'm going to have 36 plus 49, which will give me 85. And then 81 plus 64, 36, sorry. This will be 117. So let's multiply the square root of 85 times the square root of 117, which will give me, just multiply 85 times 117, and you'll get 9,945. Now this will simplify, but nobody cares, okay? So the cosine, let's do the inverse so that we can get to our angle, okay? So let's plug this into our calculator. Second cosine, I don't know why I have it on graph, so let's get out of here. Okay, so second cosine of 12 divided by the square root of 9,945. What's our angle going to be? 83 9/900 degrees. So theta is 83 9/900 degrees. It's not 90, 0, or 180, so we know our vectors are not parallel or perpendicular, but this is our angle between vector A and vector B. All right, y'all work out all the problems that I didn't do in addition to the other worksheet, and let me know if you have any questions. Y'all have a great day.